Hi, myself Rashti Parikh and my student ID is 1014198828 and this is my submission for assignment 4. So the goal of this assignment is to demonstrate how we can increase the accuracy of a model and reduce overfitting using the techniques like regularization and data augmentation. I'll walk you through the full process from data preparation and model building to training and detecting the overfitting and applying the multiple solutions to visual comparisons. So, first of all, I've used the Fruits 360 dataset from Kaggle, which contains over 100,000 labeled images of fruits across 179 classes. I downloaded it directly using the Kaggle AI API to avoid long upload times. After extraction, the dataset is organized into training and testing folders, each containing one subfolder per fruit class. So yeah, and then further, the data processing and splitting. I used Keras image data generator, as you can see here, to normalize the pixel values and perform a validation split of 15% from the training set. The generator also resizes the images to 100 by 100 pixels and prepares the data in batches of 32. So I created these three data sets: training data from 85% of the training folder, validation data from the remaining 15%, and the test data from the original data folder. This gives me uh, yeah, this gives me around 78,000 plus training images, 13,000 plus validation images, and over 300 test images. So yeah, as you can see here, these are the data. So further, next I define a simple CNN architecture. It starts with three convolution layers with increasing filter sizes 32, 64, and 128, each followed by a max pooling layer to reduce spatial dimensions. Then I flatten the output and add a layer with the 256 neurons, followed by a final softmax output layer with 179 units, one for each fruit, as you can see here. Further, I've created this plotting training versus validation accuracy loss graph. Before that, I trained the model, and then as you can see here in the two graphs comparison, this graph shows the overfitting clearly. The training accuracy keeps improving, but the validation accuracy stops rising or even drops slightly. Similarly, the validation loss increases while training loss the decreases. This is a textbook case of overfitting. The model is learning the training data too well and not generalizing. Next, to reduce overfitting, I added a dropout layer after the dense layer. Dropout randomly disables some neurons during training, forcing the model to generalize better instead of memorizing. I retrained the model with the dropout using same dataset and training conditions. The validation accuracy became more stable and the gap between training and testing validation loss decreased. So yeah, next I applied the data augmentation. This involves randomly transforming the images the during the rotating, zooming, and flipping, shifting. So model sees more diverse examples and doesn't memorize the training set. So yeah, as you can see here, I retrained the dropout model using this augmented data. The validation accuracy improved even more and overfitting reduced significantly. So next up is the over parameterization demonstration. To show how too many parameters can be a problem, I created a deep model with 4 convolutional layers and multiple dense layers, a classic case of over parameterization. It quickly achieved high training accuracy but performed poorly on the validation set. This proves that a bigger model doesn't mean better results, especially without regularization. So as you can see in the graph, Combined graph comparison. So this final graph compares all models, the baseline with overfitting, the dropout model, the model with dropout and augmentation. You can clearly see the improvement as we applied these techniques. So yeah, that's all. So in this assignment, I demonstrated the data loading and pre-processing, training a CNN, detecting and reducing overfitting, applying a dropout and data augmentation, over parameterization effects, and visualizing results with 6+ graphs. So all goals for this assignments are achieved, and that's all from my side. Thank you.